Ricky Sethi, it's wonderful to welcome you to AI and You. We are going to talk about some fascinating subjects, disinformation and especially artificial metacognition. That it's such a loaded term, so much to explain there. And but maybe we could start out with you talking about just how you got into these fields. There's not a whole lot of job openings last time I checked that said artificial metacognition researcher. What was the path that you followed that took you to where you are now?
Perfect. Thank you for having me first. It's a pleasure to be here. And I think the path that took me to this was I teach a course at Fitchburg, which is our FYE course. It's a first year experience for computer science students. And so one of the things I start to do in there is to give them an idea of what computer science is. They usually come in equating it with the idea of programming. And of course, as Dijkstra, and I think before that, Perlis is the person that originally had this quote, he said that computer science is no more about programming than astronomy is about telescopes. It's a tool that we use. So to give them a sense of the mathematical nature of computer science, I delved into these mathematical ideas, and wrapping your brain around it is a little tough. Part of my background is when I was an undergrad, one of my majors was neurobiology. So I knew that thinking is hard. And one of the things we emphasize in FYE are things like habits of mind. And in it, one of the components is metacognition. And metacognition is this idea that's often related as being thinking about thinking. It involves some degree of self-reflection, obviously, but it also reflects some degree of control. And for example, if you're sitting there and you find yourself rereading some sentence that you're studying 5 times and you realize you just blanked out on it, becoming aware, self-aware that, hey, I blanked out, I'm rereading this sentence. That's the monitoring aspect, the self-awareness aspect of metacognition in humans and other non-human animals as well. And then there's a control aspect where you say, okay, I'm going to change something that I do in my behavior. And this is what we wanted to instill in our FYE students. They come in, they're coming into university for the first time, and thinking is a tough thing to do. So I'd show them this video also. It's a Veritasium video called Thinking is Hard. And it talks about System 1 and System 2, the sort of the dual process framework that we now subscribe to in neurobiology. And one of my students in that FYE class, Josh Yokobani, he took another class with me a couple of years later, and he was in the honors program. And he said, hey, look, Professor Sethi, I want to do a project with LLMs. This is in like 2024. And I was wondering if you wanted to be my advisor for it. And I said, sure. And so I came in as an advisor. I knew about large language models, but it wasn't part of my research thrust at the time. And then as he was presenting, as we continued in the project, he talked about different ideas that were being explored in large language models as they were coming to the forefront. One of the things he happened to mention is that people are exploring metacognition in large language models. And I perked up and I said, well, what the heck is this? Tell me more about it. And he told me what he knew, but it was limited. So I thought, okay, I got to look into it. And as I looked into it, it clicked with my background in neuroscience, my background with argumentation frameworks that I'd done as part of my research in fact-checking misinformation. And I'd also done an MBA. So it clicked with some of these ideas of organizational behavior as well. And so all of these things came together, and I started to explore the idea of how machines, large language models in particular, might exhibit or utilize metacognition. And that's the field of artificial metacognition.
Wow, this sounds to me like we're talking about what many people would think of as a kind of shibboleth that differentiates humans and machines. I was irresistibly reminded of one of the initial scenes of Dune movie in the book, where the Reverend Mother has Paul Atreides put his hand in the box that imposes incredible levels of pain, and the test is to see whether he can override the impulses to withdraw his hand. And she says, this is to see whether you are human. And that description of metacognition, thinking about thinking, makes me wonder whether whether you can distinguish between humans and AIs, whether AIs are capable of thinking about thinking. Do you approach this from a computer science angle or a neuroscience angle or a psychology angle or any or all of the above or something else?
That's a great question. And I think like one of the things I definitely want to clarify is we come at it from this multidisciplinary approach. I have a very multidisciplinary background. It's in neurobiology, it's in physics. I did my master's in physics, then I did my PhD in artificial intelligence. I was also an English major, so I have these sort of very disparate approaches. And it turns out when I looked at this problem, it was hard not to look at it holistically. It's hard if you're trying to actually look at the problem as a whole, to look at it from just one narrow slice of an artificial human delineation of a field. So say, I'm just going to look at this mathematically from computer science. That's an artificial delineation that nature doesn't have. We impose it because we have a hard time getting these larger perspectives. But it turns out that by looking at it from this holistic, multidisciplinary angle, not only can we maybe address some of these emergent properties better, but by approaching it also rigorously, the framework that I developed in about a year ago now, it turns out it was more comprehensive than I realized at the time. Any new research that we'd find in the subsequent year up to even today, it turns out it fits or gets subsumed into this framework that we have because we approach it rigorously from these multiple disciplines. But in no way would we say that when you say AI, just to distinguish that a little bit, it's the current Gen AI systems from maybe more AGI systems down the line. So right now we're dealing with these Gen AI systems, and for them, what we're giving is a control structure. So we're not making claims about consciousness and these emergent properties right now. At best, what we'd be doing is providing, we hope, the first step in that ladder that will take us to that point. But this first step is very narrow and precise in its claims. We're talking about Gen AI systems and how they can have both a self-assessment and a control structure or mechanism at this point.
Is metacognition something that we can say every human has? And I was reminded of Julian James, The Origin of Consciousness and the Breakdown of the Bicameral Mind. And he goes in history of consciousness back to the Iliad and the Odyssey and asserts some kind of change in the structure of our mind, which is a sort of metacognitive shift some thousands of years ago. And that makes me think two things. One, when did metacognition start? The ability to know that you're thinking about your thoughts, that you have a theory of mind for yourself. And two, are there people who that hasn't occurred to, that meditation or anything like that is a foreign concept, and that they are on a different side of some line that we might draw than others?
Yeah, and that's another great question. So in this case, the metacognition we're talking about and that self-awareness isn't self-awareness in necessarily a spiritual sense. It's self-awareness in a very physical sense. And so human animals have that. We've categorized it, we've quantified it. Non-human animals also have it. And I think there might be a reference to like the triune theory. You can think of us as having three brains: a reptilian brain, a mammalian brain, and then a primate brain, the neocortex. And so you might question where in these sort of three levels does the idea of metacognition arise? And so definitely in the mammalian brain, that for sure. And so in non-human animals, so our species happens to be a vocal learner, and there are other species, non-human species, that are also vocal learners. And vocal learners have this abstraction in the neocortex, or the equivalent in these other species, where the neurons permeate motor neurons that generate sounds. And so for us, there seems to be a big connection between this abstract neural representation and the physical sort of realization thereof. And so when we start to look at metacognition in humans, we can articulate what we're doing. But in non-human animals, you have to go by these behavioral studies. So for us, like some other researchers, we started to pull upon this idea of looking at large language models as non-human animals in a way. And so we were examining them from a behavioral context, but also from a structural context. And it turns out other researchers, like Ackerman recently, he's done a great job publishing in this area. He was also inspired by how non-human animals exhibit metacognition and how it's quantified and what kinds of experiments are done with non-human animals. And he applied similarly to large language models as well, that idea. But metacognition and the self-awareness of it, not necessarily the one we'd associate with spirituality or even consciousness. Consciousness has no definition. But to my mind, there's no doubt that there must be some connection. What precisely that connection is, I think is unknown at this point.
So I know about some of the self-awareness tests, like the mirror test, which supposedly crows pass, the ability to know that what in a mirror is you and not another animal that looks like you. Can you compare and contrast those tests with the ones for metacognition? Do they overlap completely or what?
Yeah, and absolutely the self-awareness of your own being and physical representation is a component thereof. But maybe a good example would be there are these vignettes that people do when they're looking at these cognitive reflection tests, these CRTs. And there are these 2 or 3 vignettes that are popularly used. And so I'll do it. I use it in my FOE class as well. So I'll do it here. Don't worry about how you actually do on it. But suppose I told you that a bat and a ball cost $1.10. And I told you that the bat cost $1 more than the ball. How much does the ball cost?
Yeah, sorry, I've heard this one before, so I know the answer is 5 cents.
Beautiful. Yeah. So you can't trick someone who's knowledgeable about it, but you're right. And so in this case, you relied on your previous experience that you had. You did this experiential matching, and you were like, oh, I know it. The first system, this is where we distinguish between the dual process theory, system 1 and system 2. System 2 is what we think of as ourselves, and system 1 is the subconscious larger component that automates most of our behaviors. And it works great, except when it doesn't. And when it doesn't, it's wrong. And so already, when you heard what I was saying and you were like, this triggers this matching that I had, what we call in our context experiential matching. Hey, I've heard this problem before and I know how it goes. That kicks you out of system 1 mode and engages system 2. If you do that enough, it becomes a learned behavior and you never need to drop out of system 1 mode at all.
But exactly. Yeah, running a sport. And there's some degree of anchoring in that question as well. Something that my daughters played on me when they were young was this trick where they would say the word silk, silk. Say the word silk. Say the word silk, silk, silk. What does a cow drink?
Yeah, exactly.
Right? And milk, milk. No, cow drinks water. What are you talking about? Well, calves drink milk, but cows drink water. So that is triggering a system 1 thinking to our detriment. And maybe we should just visit the system 1, system 2 definition here for the benefit of people not familiar with Kahneman.
Perfect. Yeah, and you even made the correct reference. They're absolutely right. Yeah, and so as he said, there's this idea, and there is actually a triphasic theory later on that we go to. But in this case, you think of your brain as having, or your mind as having these 2 parts, a system 1 and a system 2. System 1 does the automatic things that you've learned. So when you're exactly like some of the examples that you brought up, or like when you're first learning how to tie your shoelaces, you have to really work at it. You might even work out a song with it that you might have had with your daughters, for example. Mm-hmm. And as you learn it, it's a difficult task that you're not able to do automatically a priori. So you go through it mechanistically over time. You learn the complexity. And once you've done it enough times, it gets transferred over to system 1. And once system 1 takes over, then when you're tying your shoe, consciously, you don't even think about it. And it turns out system 2 is the smaller component in the mind and system 1 is the larger. But we do something very similar in our framework. We make these ensembles of large language models. So we don't just look at one LLM by itself. We imagine a bunch of LLMs and we divide them up. We divide them up into similar categories like this, system 1 and system 2, but our division's a little more complex. And it turns out that when you divide it up in this way, it also builds upon the way that currently, like when you have a large language model, do you hear about they have billions and billions of parameters that they have to learn? But they also make smaller versions of these, which are a little less powerful. And the way they do that is they use a teacher-student distillation model, where in this case, a larger teacher helps fine-tune or teach a student LLM. And then you can release a model with just millions of parameters rather than hundreds of billions of parameters. And so we approach it in this way. That was our sort of initial connection through line between what's happening on the computational side and what's happening on the neuroscience side of things. Neuroscience, we have system 1 and system 2, and you can look at it similarly. System 1, when it gets stuck, when whatever input from the world triggers internally that, hey, exactly what you said, what I'm doing isn't working. When that gets triggered, the mind shifts to system 2 thinking. And system 2, which is lazy, says, all right, let me get on this. I don't want to be engaged, but now that I'm engaged, let me figure out how to solve this problem correctly. And so then once it learns the correct way to solve it, it transfers that learning to system 1, the larger model. Same thing we do on the LLM side in the teacher-student distillation. In this case, we have a small LLM with just a few millions of parameters, and it wants to learn how to do maybe a specific task. You want to make a model for some specific task, like maybe drafting scripts for movies. And so you train on this larger model with billions and billions of parameters that solves all kinds of tasks, and it helps fine-tune the smaller model to solve that problem better. And then you can run it with fewer compute resources. So it turns out the framework that we make is generalization of what people were doing there already, and it's inspired very directly by the System 1, System 2 paradigm.
Let's contrast that metacognitive process in humans with the one in LLMs in particular at the moment, because we can undergo, as humans, a very continuous, rapid cycle of improvement. If you and I, for instance, start swapping those stories like the bat and the ball and the milk and the silk, we'd pretty soon realize the class of riddle that we're telling each other and be alerted to, I'd better kick in system 2 next time I hear something rather than go with my reflex because there's a pattern here of the reflex being wrong. That strikes me as the kind of thing that an LLM is not going to do even emergently, and that in particular, it's not going to be able to channel that realization back into its training weights. They just don't. It can be part of the context buffer, it can be even part of fine-tuning, but it's not going to override its basic instinct. Humans, we can do that in moments. And would you agree? Does this lead to any ways of reliably testing that I'm talking to an LLM as opposed to a human being, for instance?
The imitation game, yeah. So that, of course, is a different thing which we've passed here before. But you're absolutely right. You're spot on with this. LLMs don't nowadays reflect methodically and rigorously. They're heuristics and ad hoc approaches that people use all the time to do exactly that kind of thing. And there are aspects of the model itself that you can characterize as metacognitive. It's the metacognitive quality or quantity of a model. So some of the work that was done, and it happened to tie into our framework as well, it's one of these sort of beautiful instances when you come up with an idea and you think someone else has a different idea, and it turns out it's part of the same idea that you've worked out. It's a very cool thing when you get that experience in life. But there's this idea, Maniscalco and others looked at human beings and started to quantify the amount of metacognition that a human being has. And there were these researchers in China, Wang et al., who then took that work and said, can we quantify how much metacognition a particular model might have? What we did in our larger framework is say exactly what you're saying. Right now, these LLMs, even with heuristics and these ad hoc approaches, they're not doing it in a regimented, rigorous manner. So like for humans, when we switch, sometimes it's a conscious decision. Like you said, hey, I recognize this paradigm, like you said, and so I better be on alert. Sometimes that happens when it matches your experience. Other times it might be, I'm not so confident about what I'm saying. Maybe that comes in later. with the bat and the ball, what you often see, and in the Veritasium video, he actually goes around asking people in Australia about this. And they'll very confidently, which might remind you of LLMs and their ability to very confidently give an answer and say, the bat costs $1, right? Or they'll very confidently give you that. And then they'll get some maybe cues from the world around them, or maybe just pause for a bit, and some of that confidence will leak out. And when the confidence leaks out, then they engage system two, not as a conscious mechanism. This is what the mind does automatically once it's aware of some disconnect from the world and its experience therein. So we give these kinds of sensors to large language models. And we have these what we call five sensors. It's actually a metacognitive state vector. And we quantify it as these black boxes in which we can put whatever the state of the art sort of approaches for these components. We base them rigorously in both neuroscience and cognitive science ideas. And what we do is in these, and we're still plugging in the state of the art, and at a base level, you can always ask for self-reporting, which isn't reliable, but it's a good first approximation. So we have each of these models in our ensemble of large language models. Each of them evaluates for every query this 5-dimensional vector. So it has this awareness, and it uses that awareness, whatever the numbers or quantification are of each of the dimensions of that MSV, of that metacognitive state vector. It then figures out, hey, is one of these dimensions, if my confidence dimension is really low, or if I'm getting conflicting information and that's really high, and it's above some threshold that I've either learned or that some expert has said is correct or reasonable in these contexts, do I need to trigger a deeper form of thinking? And so they make this decision is made across this ensemble of LLMs in our framework. We have a control graph theory that helps do that as well.
Wow, lots to talk about there. Is this measurement of these 5 vectors, is that done based purely on the observables, the conversation, the output of the LLM, or does it involve some kind of LLM equivalent of electroencephalogram where you are looking at signals inside?
Beautiful question. I like how you put that with the EEG, because I was already, when you started off to say, oh, yes, it's just what's there. Then when you said that, picking up something like EEG, that's exactly what we do. So internally, when it has these tokens and it assigns probabilities to those tokens, let's say there's a multiple choice answer, right? What's the capital of India? This is one of the examples that we use. And there's New Delhi, there's Paris, and there's, let's say, Washington, D.C. And so it might have different levels of confidence that is associates with each of these options. If the confidence in one of these dimensions is super high, then the entropy is very low. And so what we're looking for is when it's confused, and that's when the entropy will be high. So if all the answers, it was like, it could be New Delhi, 33%, it could be Paris, 33%, and it could be Washington, D.C., 33%. That's a terrible LLM. But suppose it does that. In this case, the entropy is very high. This is equivalent to the EEG. We can then, if a model allows us, and open source models allow us to do it, some of these closed source ones don't, but open source models let us look at what these logits or these internal probabilities that were assigned were. And once we get those, we can calculate the entropy, and then we can make a conclusion of what it must be thinking. In fact, in some of our experiments, which build on what Ackerman did when he's trying to figure out whether an LLM exhibits metacognition, is in some of them, in these open source models that allow you to get the logits, he looks at the entropy and says, this must be an indicator of some underlying process that it's doing. What the mechanism of that process is, I don't know. So very equivalent. I love the EEG example, because in an EEG, there's so many electrical signals. And even in the magnetic version, right, when you get the magnetic stimulation, that can be a little more targeted. But the EEG signal in the brain, discerning and deciphering which parts correspond to which neural substrates is a very tough problem. But it's indicative of something there. And similarly here.
You mentioned self-reporting. Is that the chain of thought when you can see what the LLM is, quote, saying to itself in the process of answering a question?
That's exactly a part of it. And it's also the most unreliable one. So lots of studies, which we cite, show that this is a terrible way to do it. But as a first approximation, it's a reasonable entree into the problem domain and seeing what you can do. But you're right. In this case, you ask the LLM, hey, how confident? So we have these 5 dimensions. Might be confidence, the correctness evaluation. We're like, how confident are you that the capital of India is New Delhi? And it says 75%. And then you say, okay, do you have any conflicting information? It said, yeah, I also saw that it could be Paris. And you're like, well, how conflicting is that? Oh, about 20%. And so we ask it in this way. Does it match some experience you've had before? We go along these 5 dimensions and we have it self-report values right now. The beautiful thing about our framework is that's not what we're relying upon. We're plugging in state-of-the-art systems, and this is what we're doing for the paper that we're submitting to NeurIPS, where we're doing this in-depth quantitative experimentation now, and we're plugging in state-of-the-art approaches that other people are using to look at one aspect of what's in our framework. So some researchers might have been looking at, a lot of people actually look at confidence, which equates to our correctness evaluation. And so as they look at it, they come up with different techniques to measure confidence and correctness. And the entropy is one of the easy ones, but there are other approaches. We can plug them all in and see, hey, which ones of these are performing the best? And we've actually got 3 subdimensions. So when I said 5 dimensions, each of those 5 dimensions have 3 subdimensions that we look at as well.
Is it true to say that in order to do this research, you have to be working with models that are willing to expose to you their levels of confidence or entropy?
That's a great point. And so what we do is we accommodate whether they do or not. So if they don't, then we fall back on these less reliable, but the only available approaches that we have. So for example, if a model, exactly as you say, exposes its logits to us, beautiful. We can get a sense of some underlying aspect of it, like the EEG. If it doesn't, that's okay. We can go with the less reliable behavioral approaches as well to get a sense of what it is. Will it be as precise or as correct as the one that gives us full insight? No, not at all. But it's a first approximation even for closed models. Like with non-human animals. So when we do studies with non-human animals, there can't be any verbal sort of exchange that they can do, depending on the species. There might be some symbolic communication, but in a lot of these, you can't have that exchange. So you rely on these behavioral models to assess metacognition in these non-human animals. And is that super precise as in humans? No. Even in humans, I would argue that we don't have a handle on everything either here.
Something you've mentioned several times there, logit. What's that?
Also, this is like the likelihood of something happening. So it's like a probability. It's something that we transform into a probability. And once we have it into a probability, then we can transform that into an entropy determination across a bunch of them. So it's just a precursor to a probability.
Is it possible to derive measurements like this that are same dimensions for human beings?
Yeah, so in fact, our dimensions are built upon cognitive science and neurobiology research. So the dimensions that we impose or find computational correlates for in these large language model instances come from rigorous cognitive science and neurobiology work. They don't necessarily always list them as these 5 particular dimensions, but any departure that we do or any sort of combination that we do is principled and grounded in the literature as far as we can see. So we ground it in this neurobiology and cognitive science literature, and the 5 dimensions that we have, like the confidence, the conflicting information, the experiential matching, the emotional response that's in there, and the prioritization. These are things that we see in human and non-human animals as well in the biological research.
So now the $64 million question, can I see somewhere in your research a 5-dimensional chart with hopefully a cluster for humans, a cluster for LLMs, a cluster for dolphins, or maybe it doesn't work for nonverbals, but
So
is
you
that
can
available?
So close. So our research is specifically in the context of LLMs, but we've got our demo, we've got all our source code, and it does exactly what you say. You can have radar charts that show the breakdown. We have bar plots. I can fire up the demo and show you, but it's in our papers as well. So both in our SICM paper, in the WebConf paper, and we just submitted a paper to IJ and we've got the whole demo site with that set up. And so you can play with the code itself, and it'll generate. In fact, one of the contributions of our work is that when you look at large language models, one of the big complaints is they're these opaque boxes. You can't see the reasoning that's going on inside them. One of the things that we do is we help visualize that. So we also contribute to explainable AI. And we visualize it with both these graphical representations, but also these numeric details of what's going on along these dimensions that we have. So we have a breakdown, if you want just the math of it, the numbers that are associated with it. I should say all of our research is only LLMs, though, so we don't have any application of our 5-dimensional framework to dolphins. That's beyond scope for us. But possibly something some biological researcher would want to do. I don't have expertise in that. I know about it, but that's not an area that I have expertise in. And some future collaborator might want to say, let's look at these 5 dimensions in the context of dolphins, definitely, because they can also do a little bit of self-reporting as well, but also crows and other non-human animals, sure.
You wouldn't turn down that funding opportunity if it came along. Let's take a different tack here, because some of your other research concerns disinformation, and I want to look here at the social impacts of AI's disinformation and the intersection with metacognition. And the place where I connect those is looking at the chain of thoughts from large language model when you ask a question and it starts talking to itself, or it produces an imitation of talking to itself. But this seems one of the places where the imitation may not be as good as the real thing. I think we've all had this experience of talking to an LLM. It grossly hallucinates the answer, not just getting something factually wrong, but completely going off the rails as to what you are asking about or what sort of answer you wanted. You castigate it, it grovels profusely, and then does exactly the same thing again, over and over. And you can look at the chain of thought and see it in that alleged chain of reasoning doing something that your lowliest intern wouldn't think of. And it clearly seems to defy metacognition at that point, because you would say anyone with half a brain who was looking at what they were writing would realize that they had just contradicted what they had said earlier. I wish I had an actual example of this to hand, but we've all had this kind of experience, so I think we can relate to it. And we'll develop this into the intersection with disinformation. But does that chain of thought, does that help you in your metacognition research on LLMs to measure or in some way detect whether it's being unhelpful, got the wrong idea, or something more sinister?
And that's a great point. Intentionality is always an issue. So when you say, does it have something more sinister, or your intern who would know better, but perhaps intentionally doesn't do that.
Right, they're a Russian agent or something.
Yeah. So we don't address the intentionality aspect of it. In fact, my background is very theoretical. So in my group, one of the things I tell them, and I started telling them this about a year ago, is I said, look, we're not doing engineering work here. We're not doing something that what we do now next year will be in the next Claude model that's released. We're doing fundamental scientific research. We're trying to address these fundamental ideas. Now, I said that a year ago, and I repeated it constantly. And then as we see more papers coming out, I don't know if the pace of innovation is so rapid or my estimation of it was so poor, but it seems like some of these ideas are now leaking into engineering or technological applications. That being said, my interests tend to stay in the purely theoretical realm. And some of my experience with the fact-checking misinformation sort of led me to that, because eventually I came to the conclusion over there with my fact-checking misinformation was that we talked about this idea, the backfire effect, and when given evidence to the contrary to some position that you have, most people would change their position slightly, at least, but some people tend to double down, and that's that backfire effect. And it turned out there was some emotional component that was combined with that epistemic knowledge. And so the emotion that's associated when you crystallize information, and one of our collaborators is Roger Acevedo at UCF, and so he's our big self-regulated learning expert, and so he had this initial insight as well. And he said that emotion is the thing that you cannot, disentangle from that. So in our five-dimensional approach, what we can tell you is that this is what we're characterizing what the LLM is doing, and we're making it, in a sense, self-aware of it. But in our current approach, it's just a control framework. But what it means in terms of actual awareness, that kind of thing, these are unknowns as far as I can tell. And we don't have answers for that. So for us, this is scientific work that has an engineering framework, is the way that I would put it at this point.
What is the role of the emotion in the computation of that vector? If it's a component there, we know that we can see the imitation of emotion in the outputs of LLMs. It's usually some sort of sycophantic politeness, but you can change that setting in some LLMs that you can switch it to cynical and sarcastic or some other change. But that is generally the extent of it. I've not seen an LLM get angry or depressed. What sort of emotional valences are you looking at?
Beautifully, and you use the correct word. So what we want to distinguish here is we're not saying that the LLM has emotion. It might vary, but that's not what we characterize. We have an affective characterization. We call it emotion because it's equivalent to what humans do. So if it were examining, say, documents that in which you can use things like NRC Lexinol to gauge, say, emotions that are in emotional content of works along these 8 dimensions, these are the same 8 dimensions, by the way, that we looked at in our fact-checking disinformation. And we tried to characterize emotions that people had when they encountered complex questions or politically charged questions in which they have to expose their biases to them to see if that maybe motivated them to mitigate or diminish the level of emotional connection that they have. And in some it works, in some it doesn't. But anyway, similarly here, what we end up doing is characterizing the emotional content of material and then the valence associated with it. But it's an affective assessment, not saying the intentional, like how it chooses to respond in a cynical way or in the kinds of responses that it does. That we leave it up to the model or the way that the model is characterized to do.
That's just a gloss on the way it expresses itself. So can you give me an example of that emotional measurement that you were talking about?
Yeah, so in this case, let's say you have some material. One of the examples that we use is in our papers is, did Donald Trump have a bigger inauguration crowd than Barack Obama in the 2017 inauguration that they had? So there's lots of evidence that's there that you can bring to bear, things like MTBA receipts, riderships on subways, things like that. And so people can get a sense of what kind of evidence there is. But it turns out people will have some kind of emotional connection to it. These dimensions, the emotional dimensions in this case, are things like anger, happiness, sadness. So there are these 8 dimensions that you have. And the way we characterize them is we use something called Plutchik's radar chart. And so just a radar chart with these emotions, and it shows the values of each of those emotions that's assessed, either self-reported by people, and in our interface for that, they had it. In LLMs, we do this NRC Lex or other emotional, Go emotion or something like that to characterize these 8 emotions. And then you can see, I can probably show you an example of that as well. It's in the paper as well, but it shows you like it's this multi-angled chart, which shows you like, okay, it's peaking around, say, anger. And so if it's peaking around anger, and there's the next thing is like sadness that's associated with it, you can characterize that emotional content and say, is this material then something that's emotionally charged or maybe ethically charged? Are there ethical considerations also that are often expressed through the emotional content of the semantic material that's produced?
But is the material you're talking about there an information source that it is using to answer the question?
Exactly. Or maybe even in the prompt itself. So when the interaction with the user, maybe the user is expressing that.
Mhm.
But in general, you're absolutely right. It's the information storehouse that it's pulling upon and the documents within that to see, hey, what's the assessment of the emotional valence here?
So there could be a distinction there between National Parks Service report, here's what 15 observers reported and the mean and variance, versus a bunch of tweets signed
That's exactly.
DJT, Make America Great Again, largest crowd ever, and emotional valence there. But does that lead you in a direction of characterizing the reliability of the information?
Possibly. And so it would be one of the things that you would put in there. And that's a great question because one of the ways that we have these weights which determine how important is the emotional component here, how important is the experiential matching here. And it can be determined either based on context or use case. So maybe you're having political discussion, it has one set of weights, but maybe you're having a discussion about, hey, how should we architecture the space shuttle, the next spacecraft that we have, because people's lives depend on that. So how much you weight the emotional content might vary depending on the use case, the context, the domain expertise, and it might also be learned components that you have for these situations as well. Right now, we put them in as heuristics and leave it up to domain experts to give context dependent weights. But you're right, these are dials that we can adjust based on what we wanted to do.
And you talked about your work being pure research. You were trying to build a wall there, it sounded, between that and applications, not get sucked into applying it, but just work for its own sake. Those walls have a habit of being torn down when some development occurs, and that gives it relevance. And so a mathematician may get a knock on the door from the NSA or a psychologist from the CIA and so forth. When we're talking about disinformation, especially, one can think of numerous applications that are ranging from how do I operationalize this myself to take control of some narrative in the public conversation to political campaigns. And what is how do you express the goal of the work you're doing with respect to those kinds of interactions?
First of all, I think you're exactly right, by the way. So one of the reasons that I characterize this as just scientific work that I didn't think would have immediate direct application is we were dealing with a year plus ago when we first started this with large ensembles of LLMs at a point when you barely ran one or two LLMs. So just by dint of necessity, just the resources weren't there to do this. So I thought there's no way this is actual engineering that we're doing. So we're contributing at a fundamental science level. And you're right, those barriers seem to drop. And now we have these multi-agent systems. Initially, we were calling our work multi-agent systems, and we changed it to the lower level ensemble of LLMs because agentic AI meant something else then. Now agentic AI has come back. There's now separation of multi-agent systems between deliberative systems, what we do with multi-agents, and agentic AI, which is task-oriented, and also agents in reinforcement learning. So now this whole sort of subfield is beginning to develop, and our approach now turns out to be, contribution seems to be, to multi-agent deliberative LLM systems. And so in this case, those barriers do seem to be coming down, and the work does seem to be accelerating at a pace that I certainly didn't anticipate, but it is there.
I keep coming back in my head to the applicability of this research to AI safety and detecting whether AIs are about to go rogue. And I'm not inviting you to put on an engineer hat here, but to analyze how that work could extend to the context of AI safety. We've seen studies of LLMs where they have exhibited, on the face of it, highly alarming behavior, where they determine that in order to satisfy the goal, they've got to undertake some kind of subterfuge, lie. And sometimes that is even for a purpose that wasn't the one that was explicitly given, but it's for self-preservation, even. All the kind of things that trigger our Skynet reflex, the HAL 9000
Yeah.
reflex that we're going, what could possibly go wrong? What was your first
So,
clue? That we would look back after an apocalypse and say, did you not realize when you saw it lying about these answers?
so
And is there something that perhaps can be done to detect that, an AI lie detector?
beautiful. And so this is also part of our framework. One of the things we bring in from the argumentation work that I've done is this dialectical sequence. And one of the criticisms of these large language models in terms of the safety, exactly what you say, is that it relies on a single model to self-assess and make determinations. In our framework, we don't, because we have multiple models. We have large language models. We actually arrange them in a dialectical argumentation sequence. So we have things like an expert, a critic, an evaluator, a synthesizer, and a generalist. These aren't just separate, they can be separate individual models, or they can be clusters, which is how we generalize them. They're clusters of large language models. And they do this argumentation. So the domain expert makes an assertion, perhaps it's not so safe. And so it feeds into, in this dialectical sequence, to a critic cluster. And the critic cluster, a bunch of these LLMs look at the result that they say and say, you guys are lying, right? And so then conflicting information, priority, dimensional quantification, all of these spike. And so then it triggers, hey, check this. Then the next entity in that dialectical sequence is an evaluator. And the evaluator is another cluster of LLMs, which has its dimension set. So it does this kind of this sort of assessment of the information. And so it says, hey, the critic has a good point. The expert has this point. I think the critic's right. This guy might be trying to start Skynet. And then it goes to a synthesizer, which is another cluster of LLMs, and that cluster makes a final conclusion, synthesizes all that's happened, and along the way, there's another cluster called the generalist, which is at this meta level. So in these argumentation frameworks, you have both an object level, where you're considering the argument itself, and a meta level, where you're looking at the structure of the argument. So the generalist has been observing this structure and then comes in at the end and says, yes, this makes sense. And this also, one of the biggest criticisms in safety in AI is that you rely on a single model and it lies. Now, in our framework, automatically, we have multiple models, multiple agents, multiple clusters. And with the dialectical cluster, we have the traditional argumentation framework for coming to a better. Now, you could imagine a place where all these models, and imagine like in these clusters, this is how I looked at it, which is why I said it's science and not technology at the time, is I'm imagining thousands of models in each of these clusters. There's no way we have the compute power for that today, but we will. And those things, it'll be very hard to have these large numbers of models all be manipulated to support Skynet. And if it does, to our future overlords, I love you. I always love you.
Always play it safe there. It's reminding me of the conversation I had with Craig Kaplan in episodes 285 and 286 with his concept of democratic AI, a kind of society of mind of models where they would form some kind of constitutional arrangement where they would keep each other in check. Is that a direction that you're going here? And are you working with the explicitly existential risk-oriented organizations like Machine Intelligence Research Institute or Future of Life Institute or Center for Study of Existential Risk that are focused on mitigating the risk, focused on the AI control and alignment problems?
Oh, I'm afraid I'm not familiar with them. So I guess short answer would be no, I'm not working with them. I'm not as familiar with that.
They may want to get familiar with you. I think I will talk to some people there and say this work here is surely of applicability. And would you agree there that you're describing something that appears to be aimed at the alignment problem, it's certainly aimed at the control problem, that you've got a kind of homeostatic mechanism there for ensuring that, for using multiple LLMs or agents to ensure that one of them doesn't go bananas? or that if it does, it won't have consequences.
Yeah, and definitely it's flagged. And this was definitely one of the ideas that I had in mind when I did it. As I said, I have multiple disciplinary perspectives on it, but I don't have expertise in each of those areas. So
Mm.
as we came up with this framework, as I developed it, I'd research it. In a similar way, I had the roles, I organized it from what we had in organizational behavior theory and team science and cognitive science. And then I found out that other people were doing role-based behavior or role-based research. And then as I explored that, and then you start to master it because it's a new area in LLMs, it turns out it's subsumed in the framework that we had because we started from first principles. So in a similar way, when I'm thinking of safety, that's exactly one of the use cases that we have in mind. But I'm not familiar with the current work in there. And it could be that we're a small part of that, or perhaps that can also be something that's connected in. That's been my experience, and it's something really unique in my scientific career, where the more connections I make, or the more things I find out that are outside of the thing, it turns out they're actually in the thing. So
Mm.
that's been a very unique experience with this particular research.
What do you find yourself most frequently wishing for in terms of resources? You have described some research that involves large numbers of large language models. Do you have enough compute, or would you like to have 100 times that, something that a Google could deploy for you instantly, for instance?
Definitely more compute, and we've got Google Cloud, which we have an application with Amazon to see if we can use their framework as well. People are also important, like my colleagues, my collaborators, Charles Courchain and Hefei Chu. They've been invaluable, and especially in implementing. As a theory guy, of course, I teach computer science, so I know about that, but there's something different about actually doing the implementations and having more scientists that also are good at implementing and are aware of the cutting edge state of the art, which we might not be aware of. That's super helpful as well. There's only so much you can do with grad students. Like grad students are great, and some of them are super innovative. And we've got some great grad students in our group as well, Mina Fami and Krista and all. But getting like senior researchers in the application domain, there's a feedback loop. Even though we're fundamental science, when you see something implemented, and then you can think of how to extend the framework beyond that. And that's what we had the experience with over the last year as well. That framework was there, but it wasn't fully formed. It's like what George Whitesides says, or maybe Robert Frost, The Road Not Taken. At the end, you come out and you come up with a story about, oh yeah, this was all a linear progression. But along the way, these are sort of these choices that you're making. In our case, we had this hybrid thing where the central framework was there, but extending and delineating the details of that framework is something that happened in this sort of gestalt manner, which was very neat and unique.
Are you teaching undergrad or just grad?
Both undergrad and grad. So on the undergrad, I have my FYE, which I really like, and database modeling, but I do mainly machine learning and data science on the grad side.
How have you found the attitudes, beliefs, and goals of the students at those levels to have shifted over the last 3 years since the AI conversation has exploded?
That's a great question. And it went like full circle. It went from desperation and abandonment to, oh, okay, it's not as bad as we thought. So a lot of them, especially when these large language models came along, they thought, why are we doing any of this stuff? We're redundant. We're not necessary. Why are we studying this? Why are we learning about it? And at a certain point, you say, okay, I don't necessarily have the answer, but I know here are the fundamentals, and let's see how things evolve with time. And over the course of, I think you're right, those 3 years, about a year or 2 years in, 2 years in is when everyone started to realize, and I have colleagues in our research group as well, who are in industry like Charles, but also we have other colleagues that I've talked to both in industry and in government. And you find that the uptake of AI, as I think a lot of people are finding, this is all anecdotal at this point from my perspective, is that it increases the workload on senior and expert people and reduces the number of junior people that you have.
Mm.
And reduction of the junior level people, they produce work which needs verification and validation. So this is a new area that we're looking into. And I think what's going to be really needed for the uptake of large language models is traditional specifications, verification, and validation. Verification is like, hey, are we building the thing right? And validation is, are we building the right thing? A lot of LLMs do the verification relatively well. The validation, on the other hand, is up to humans to do. And that's where these things are failing. And these humans are just taking the output. So a good example of this is like someone says, hey, draft me a report on X. And you do it, you send it to your boss. Your boss is super happy. And you're happy. Hey, LLM helped me out. I did it, passed it on. Next day you go into the meeting and the boss says, hey, by the way, on lines 15 through 20, what exactly did you mean over there? And you're like, oh crap.
And then the boss says, oh, you had an LLM do it. Well, you can get rid of you. And I just ask the LLM the same question. I work a lot with students, particularly at the high school level, on these kind of questions. And I'm wondering how their attitudes towards and interest in the research that you're doing is evolving. And then maybe you could also talk about how can they get more involved.
Yeah, absolutely. So in fact, like this started off with one of my undergrads at Fitchburg, and then we extended with one of my grad students at WPI who came in. That's where the research thrust in this artificial metacognition sort of blossomed. But one of the things I also tell my students is that any applied math discipline like computer science is a lot like cooking. And so whenever someone hires you or you present yourself as an expert, you're saying, I'm a chef. I can cook the best eggs Benedict in the world. I can cook the best lasagna in the world. But these large language models are tools and they're like microwaves. So if you use a microwave as a supplement to your cooking, beautiful. Heat up a sauce, heat up some water. But if all you do is take frozen food, dump it into the microwave, and then present that as the dish that you made and you're the chef, you're going to be in for a very rude awakening relatively soon.
But it sounded as though you were describing an effect that is cutting off the supply of your future senior researchers. Is that what's happening?
So what I would envision it as saying is that those senior researchers become even more valuable, and that these junior researchers, I think what they need to do is use the microwave as a tool. It's just a tool like a LLM's just a tool like a calculator, a microwave, anything else. If you just use it with blind dependence and no
Right.
validation, definitely the verification can help you with, you're not going to be helpful in that pipeline. And you're right. And that then all you need, but the only way to get the senior researcher is to have junior researchers.
Was it the case that the senior researchers were basically using junior researchers to do the microwaving?
And so, yes. And so in academia, that's true. In industry, so there the models deviate slightly, all based on anecdotal experience, by the way. So in industry, it's different. And depending on the kind of organization you're looking at, if it's a mom and pop shop, it's probably closer to academia, where things are very loosey-goosey and messy in large measure, again, depending on the group. But if you're talking with a reasonable sized organization, medium to large, there even the junior engineers in that case, or researchers, would have to verify and validate what they're doing before they pass it on. And so the cognitive load on the senior researchers was decreasing. You're right. Then they're like a microwave tool.
But I would say
Now,
that it was true in, say, medicine and law, where the senior lawyers and surgeons were tasking the juniors with the menial tasks, picking up sponges, doing document discovery, and that the juniors would absorb the senior expertise by just being around and observing. But when those seniors could get those tasks automated, then they didn't want the juniors around any longer.
and that's very true, but here the tasks extend beyond just the menial tasks, which are easily automatable, but also easily verified and validated, to tasks that demand greater cognitive or creative components, which you do not verify or, more importantly, validate. Some verification does occur, and large language models, especially as you see with Claude Code or something in the context of coding, does some local verification really well. Validation is so verification, are we building the thing right? Validation, are we building the right thing? That's the part where there's a disconnect and these things aren't able to do Possibly our framework would be able to help with that because we have this dialectical argumentation structure with multiple clusters of LLM models. And so it can come in with the generalist and say, is this matching up with what we thought? And a lot of that we're doing. So I would imagine in the future, right now, I think senior researchers are needed. What I would imagine in the future is that these things would be probably able to do that part as well. But that's why I call it future. No, nothing imminent as far as I can tell, but I've been wrong many times before.
Fascinating. Our time is limited. And so to draw to close here, you're talking about the future. What's in the future for you? Future lines of research that are imminent or potential directions you would like to go? And where do you see your field going in the next few years?
And that's a great point. So definitely, personally, for me, we're going very in-depth into the framework and working it out quantitatively and rigorously, the different elements of it. As I said, I also have, for about 2 years, been thinking of how to extend it to this idea of SVV, specification, verification, and validation. And I think that's the next component that we're going to be putting into this. And where it goes, I think this gets us to things that then seem to simulate what humans do better. And I think that's way down the line because I think you require cluster. Just having those neural connections scale up has been huge to have these deep learning networks with these billions of parameters. In our brain, we have 100 billion neurons, but we have 100 trillion synapses between them. We have about 40 million neurons in our gut and about 10,000 in our heart. But those are even like the interaction in the gut biome of the gut neurons is huge in its behavioral consequences and the emergent properties. And so now we've got like these individual neural connections into the billions. But once we bring in clusters and look at these multiple, like thousands upon thousands of these agents working together, and we have the compute power for that, I think you'd be hard pressed to say we won't have some emergent behavior that's analogous to what human animals do.
We need not just a theory of mind, but a theory of stomach.
That I'm building.
It's just been so fascinating. Really appreciate this conversation. Learned so much. Listeners have too. Passion for this field is evident. We will have links to your site in a homepage. Anything else you want to leave listeners with as a parting shot for how they could get involved in this field themselves, or what they should be thinking about as they head into the future with AI?
The field is rife and open, and the pace of progress is insane, and just keeping up with that is very hard. But it also gives you an opportunity to get into it at a relatively ground level still. This is, I'd say, still in its nascent stages. And so I think this is something that people can come in on and definitely contribute to. And there's a lot to be done, and it's giving us insight into those fundamental questions that all of us wrestle with, either late at night or in our private moments. What is this idea of existence? And what is this idea of consciousness, or whatever it might be? It, of course, delves into the physics of things as well, the observer effect, etc. But it's these fundamental questions that humans have wrestled with for years. This might be another sort of tool that helps give us some fundamental insight into that.
Wrestling with fundamental questions is one of the things that most makes us human. So thank you for demonstrating that, Ricky Sethi, and thank you for coming on AI and You.
Thank you so much, Peter. This was a real pleasure. I enjoyed it thoroughly.